Okay, now after we completed the converter, the discussion for converter, AC to DC, DC to DC, DC to AC, AC to AC, and then we use them in switch mode power supply, DC power supply, flyback, forward, and other type of bidirectional core excitation. Today we will talk about the applications. This week and next week we will talk about the applications. Applications make you feel when we talk about them that there is useful, there is something important behind what we already study and discussed. I will start today. Definitely this week we will talk about disturbances and how we use converter for power quality and power supply, and then we will talk also about industrial application as induction heating, oven, lighting, and so on. So let me start with disturbances, and you know that it's not enough to convert from, just a minute, where is it? Okay. It's not enough to convert from AC into DC, as example in rectifier. This waveform is disturbed waveform. Yes, it is DC because it's only positive. There is no negative part of it, but it is disturbed. The same thing could be, say, if we have DC here and we want to convert into AC. If the AC is disturbed and distorted, then this is not enough to supply to my load, because my load will have a high losses, efficiency will reduce, it gets aging very fast, and so on. It may be faulted. So there are many disturbances need to be considered here. Power electronic converters converted from one form into another form of electricity, but it disturbs the waveform. Quality is an issue. Quality of the waveforms is an issue. Quality of the output voltage and current and power and so is an issue. There are many disturbances there need to be considered. There is reasons behind these disturbances, and there are many methods to mitigate, to attenuate, to reduce, to cancel these disturbance. Example of disturbances here is the overvoltage. Overvoltage, it means that the voltage becomes greater than the normal one. Under voltage when it is lower than the normal one. And outage or blackout when we have shutdown. The electricity will become zero. No electrical voltage appear across the load. Voltage spike. Voltage, you know, when these youngs or teenager, when they have haircut, they make spike in this way, right? This is the spike, what we talk about, but in the waveform. Chopped voltage, chopped voltage, we will talk about it, but you know, when we talk about commutation, overlapping and commutation rectifier, we have chopped in voltage. Part of the voltage will be cancelled, the triangle, if you remember. And harmonics also. Harmonics, you know, it is integer multiple of fundamental frequency. What happened here is any waveform contain in fundamental and harmonics. Harmonics increase, it means the losses increase and the work will not work efficiently. Electromagnetic interference is a high frequency noise. It's happened because high switching frequency. You know, we are switching the switch on and off very fast. This is the new technology. We look to the speed. So it will produce what we call it electromagnetic interference. Now here example, see, this is the normal waveform. This is the maximum, this is the minimum. When the voltage have a spike here, you see here, voltage spike here or here, this is spike. This is not good, need to be cancelled. Or the voltage increase, as you can see here, more than the maximum or lower than the minimum. We call it voltage increase or over voltage. Or sometimes it reduce, become under voltage, okay? Or sometimes we have cutoff, zero voltage. So these are some important, let me say, phenomena occurred because of the disturbances. Now here I am showing you some samples of the waveforms I measured by myself 20 years back in Sohar industrial area, okay? As you can see here, there is disturbance in the waveform. It's not pure sinusoidal. The same thing here. It's not pure sinusoidal. This is how it look like the real waveform. See here. It's not pure sinusoidal. Look, this is how it look like the waveform in a real network. These disturbances need to be reduced. The quality is important. We need to improve it. You remember also the balance and unbalanced system. We discussed them in level 2. We mentioned that if the three-phase, we deal with the three-phase, we need to make it a balanced system. We deal with balanced system. Unbalanced, it means that either the voltages are different, maximum voltage is different between phase A, B, C, or the phase shift is not 120 between them. In this way, we call it voltage unbalanced, as you can see here. See here, one voltage is higher than the other. So this is unbalanced. Voltage interruption or outage, okay, or shutdown. You see here the voltage disappears, okay. Voltage sag. Voltage sag, this is the level of voltage, it's reduced here, sagging voltage. Voltage swell is the opposite. Let's say this is the normal voltage, it's get up here, and so on. Fluctuation, this is RMS now, not waveform, RMS. The RMS is supposed to be constant, but what happens is sometimes going down, fluctuate, okay, and this is another fluctuation, this is sharp fluctuation, and as you can see here, this is fluctuation. This is chopped in voltage. You remember this triangle? We lose it because of what? Because of the, let me say, commutation. It could happen because of capacitor in and out in the circuit. We lose part of the waveform. Harmonics, you see, it's not uniform, not sinusoidal. Okay, you see how it look like the waveform here and here. This is because of harmonics. All these disturbances have many reasons. As example, I will give example. When we switch on a motor, you know the motor from AC machine that it observe at the starting, the starting current is high, 5 times the full load current. So it's observed most of the current. What will happen? Dip in voltage, reduce in voltage will occur. Even if it's for a few seconds or less than a second. We feel it sometime. We see the light, the fluorescent reduced because the motor connected to the same point gets started. Also, transient could occur because of switching for capacitor switching, lighting, and so on. Or power electronic converters lead to transient. Surge also a spike, like let me say high voltage or high current coming, and when it happens when there is switching, it could be done because of variable speed drive. We have motor, we control it, electric arc welding, induction heating, or computer, X-ray, MRI, and so on. Many components and appliances we use today in our life produce surge, spark. Now, how we control, how we mitigate, how the effect of these disturbances is depend on 3 important points we need to consider here. The first point is the type of the disturbance, its magnitude also. What is the magnitude of the disturbance? After we know what is the disturbance. The second issue, the equipment themselves. Did we design the equipment to consider any disturbances, to consider any type of disturbances? What type that these type has been considered? And the third issue is, do we have power conditioner? Power conditioner to make sure that it's improve the quality of the waveforms coming, the power waveforms coming to my load. These 3 points need to be considered to reduce the effect of disturbances meeting my equipment. Example, I will give example. You know your PC or your laptop, when you work on them and suddenly the electricity shut down, batteries depleted, let me say. What happened? You've been writing on the word. When you plug the cable to charge and operate your PC or laptop again, you will find that the word already recovered your text or your information, your data. How this happened? How this happened? Because there is inside the motherboard of the CPU of the computer, there is a circuit. This circuits contain a battery and sensors. It senses like this. You see here that this is the voltage, percentage of voltage, and with time. When you see here, I'm talking about very small fraction of time, talking about microseconds could be. When the voltage get down, reduced in this way, like envelope, in this way, until it reaches a specific point, okay, voltage reduction, or let me say the percentage of voltage from the total voltage reduce a specific value. Signal will be sent to the circuit to tell the circuit, okay, something wrong with the power supply, is going to be shut down. What will happen here? The battery circuit will take over, try to provide power for the CPU. For how long? Something in microsecond, just to make sure to save. The whole process going very fast, okay, to save the data. So this is how we put some sensing for the disturbances, and it consider these issues, the quality. Also, if you look to the nameplate, you will find information about your equipment. Part of it could be the disturbances. Example, I talk here, this is a power quality and load parameter for major computer manufacturer. See, he wrote on his nameplate, the equipment, the parameter and the range. He say, okay, voltage regulation, steady state, or voltage disturbance, under voltage, over voltage, harmonics, noise, frequency variation, and so on. You see here, many parameters. These parameters, he make a range for them as example. He say under voltage, we accept the equipment. This equipment can handle under voltage between -25 to -30% of the total voltage. He make it clear. As example, frequency variation. This equipment is working on 60 Hz, but except ±5 Hz, 0.5 Hz. So if it is coming 60.5 or 59.5, still the equipment working and can handle this variation, and so on. You can see here different rating. This is good that they make a range for the different, let me say, disturbances could occur in their equipment. You may say, okay, if these disturbances, you may say that it affect the operation of the equipment, the device, it increase the losses, reduce the efficiency. Anything else? Yes, at the end, we look to the cost, how much it will cost me. Example, I will give example. This is old cases, okay, in 1992, talking about in something happened in US in some industrial companies. Okay, they recorded that outage, shutdown of the electricity occurred for 4 hours without notice. By the way, electricity companies usually, when they want to shut down some loads, they make a notice. They send a notice that we are going to make shutdown on this date. Let me say 15th April 2021 from this hour to this hour. They make a notice, so people they consider this. They take it in consideration. Okay, so but it happened without notice. How much they lose? Around 75,000 US dollar, only 4 hours. Another 1 hour, they lose around 40,000 US dollar. 1 hour, but with notice, again they lose 23 around thousand. Voltage sag, it happened for microsecond or millisecond, but look how much it cost them. Momentary outage, it's go and back. It's how much it cost them. So at the end, any disturbances in your supply will reflect on the cost, how much you lose. For that, large industrial companies, they have their own plant, own power plant. Example, here in Sohar Aluminium. Sohar Aluminium, they cannot depend only on the network because shutdown could happen. And if it happened, they will lose millions. In a few hours, they will lose millions. Their alloy will go on, and then it will be disaster. So what they did, beside their factory, they built power plant. They use their own power plant. Okay, it's 1,000 mega, around let me say 1 gig. So they use it for the power plant because its operation, their work depend on the electricity. They cannot let me say take risk. It's not merit of gambling. They need to make sure that they have their power supply working 24 hours, 7 days a week. Okay, now power conditioner to control these disturbances, we have different type. I will just mention here to some of them. Example, metal oxide varistor. I will show you their photos, how they look like. Okay, this is used to protect from spikes. You know, remember spikes? This is the waveform. Okay, here spike. It observes this spike. Okay, electromagnetic interference filter. I mentioned that we have very fast switching, high frequency switching, which produce high noise. How we can protect this? There is filter connected on the supply. I will show you later. Isolation transformer with electrostatic shield. Okay, it's used to filter the line mode disturbances or spikes. Inductance in general observe these spikes. Fluorescent transformer, we regulate the voltage output here, and we cancel the spikes, the noise, all of them to be. It's like mitigate harmonics also, sort of mitigating harmonics. Linear conditioner. Linear conditioner is is a circuit like filter circuit, designed somehow in different ways, active, passive, parallel, series, hybrid, and so just at the end they look to reduce the specific or targeting specific harmonics which affect the output. This is how it look like the metal oxide varistor. You can see them in some circuits. They connected them. For electromagnetic interference, we see here we plugged our cable for PC as example. This is inside here is the filter, or this is another filter. This is the isolate transformer with electrostatic shield, as you can see here. Ferroresonant transformer, this one, and linear conditioner. We have, let me say, advanced circuit. This is the block diagram of the circuits. It's look like from the back like a receiver. Some box contain many circuits actually. Here example, active filter. Active filter means smart filter here. It could be connected on the same PCC point of common coupling, the point where we connect the load and supply together. It could be connected in parallel, as you can see here, or in series using transformer. I remember I published this paper when 2013. It's harmonic mitigation technique applied to power disturbances network. The previous information, some of them taken from here, because I here revised most of the methods used to mitigate or reduce or attenuate these disturbances. Electronic tap changer. Now I will talk about how we use power electronics converters to produce a good supply with a good quality. See here, this is a transformer. Have a look here. This is the primary, this is the secondary, but with different tab. Here we put triac. Triac is one of the thyristor family. Okay, triac, diac. Okay, you can read about them more in power electronic book by Muhammad Rashid. This is equivalent to connecting two anti-parallel thyristor in this way. Oh, this is a voltage regulator. Yeah, this is what we are talking about, voltage regulator. If this switch will work, the voltage from here to here will be across the output. If this switch will work, no, the voltage, this one, will appear. If this switch will work, only this voltage. Oh, just, you know, to trigger which triac, then the voltage output will change. Yeah, this is AC voltage controller. Uninterruptible power supply. Uninterruptible power supply. Look, we need to have supply which will provide electricity for my load without interruption, and even if part of the seconds, okay, they don't feel there is interruption. And this is important especially for first class loads. Oh, you have first class, second class, and yeah, definitely. First class load is the load which is highly important, because if any problem occurs to this load, we lose huge either cost. It costs me money, economics reflect on economic. As example, if I lose Sahara Navisium cannot work, we lose money, huge amount, millions. Or it could be we lose lives. As example, intensive care units in hospitals. If electricity cut off, we lose money. Communications is important. I mean, if we lose it, we lose the world will stop. Political, let me say, locations, and because there it's reflect on the countries and so on. These type of laws. The other laws could be second, third, fourth. As example, house, my house, if shutdown occurred, nothing will happen. It's not cost anything. At the end, I'm just a private, I'm person. So this is the classes of load. We need uninterruptible power supply, what we call it UPS. For computer centers, and so they use UPS. Now look how it works, these UPS. This is a line between the grid, the network. Rectifier will convert into DC. DC will charge the battery, because we need the battery as a backup later on. If any shutdown occurred here, the battery will supply the required power. Then inverter to back again to the AC with filter to make sure that we have high quality output. Then this is my critical load. As I mentioned, it could be anything. It could be hospitals, it could be computer center, and so on. When shutdown occur here, no electricity. By the way, electricity will go also here and here. Here to charge and here to the load. But if anything happen here, okay, then what we will do? We will provide the power from the battery. Now I will talk about the circuit here, or rectifier circuit. By the way, these are all converters we discussed through the semester. Inverter, I will talk about them one by one. Let me start with the first part, when we charge the battery. Okay, battery could be charged in this way. As example, we could have here, this is the supply, 50-60 Hertz, and this is rectifier circuit, could be any circuit we discussed before. And we may have a transformer for isolation, and we have here a control rectifier, or let me say a control, just one thyristor to control the output. So we control the charging, because charging is an issue. We need to make sure we are having the correct charging. Otherwise, the batteries will lose it soon, because it get aging. Or we may use, this is transformer for oscillation, it's optional, but we have rectifier with its filter. Here we use this DC-DC converter to control the charging. You see, I'm talking about the converter we discussed through the semester. Another arrangement here is we use the same rectifier with its filter, but here what we use, you use flyback or forward converter. You remember the switch mode DC power supply we discussed? We can use one of them here to charge the battery. By the way, all the previous methods, we use the same supply. Sometimes we can use different supply for the charging, to charge the battery. Example, have a look here. This circuit, we have here the 3-phase. This is 6-pulse rectifier, and it's coming here inductance, capacitance to charge the to go to the load. For battery to be charged, we have this circuit here. Okay, from external source, single phase, we have two batteries, two thyristors. Okay, inductance as a filter, and this thyristor here, it's normally off. The battery is not working. The normal situation is these thyristor 1 and 2 will charge the battery from external supply. When shutdown occurred here, what will happen? This switch will conduct, and the battery will provide the required power to the supply, to the load. How the charging of battery occurred? It occurred in two modes: constant current charging mode and constant voltage charging modes. Okay. For constant current, the current is constant and the voltage increase with it until it reaches here the maximum voltage. It will be constant. It cannot increase more than this, because the battery is designed for this. And now this situation, the current will reduce. Okay, definitely it will not go to zero because there is always some trickle charge current level, even if it's small, but it's still there. This is how the battery charged. Okay. I don't want to talk much about the batteries, otherwise, yesterday with level 4 students, they asked me about the batteries. I gave them some tips, how they can maintain their batteries, how they can keep it, how they can charge it correctly, how can they use it correctly. Anyway, here for inverter, let's go to the inverter. Inverter, we have DC input, we have the normal inverter discussed, half a bridge, full bridge, push-pull, any one of them. You use a transformer for insulation, and then this is the output. Or we may use more than one inverter. One inverter here, as you can see here, center tab on the transformer, and which inverter will work? You tell me, I tell you what output you will have. Or sometimes they use inverter with high frequency transformer, and here they use AC to AC converter, AC voltage regulator, to control the output. So I have different options. How we control, how we make control, have a look. By the way, I'm still with UPS, but I'm taking them stage by stage, part by part. I completed rectifier, the battery, now inverter, and I'm going to till I read the load. This is my inverter, my filter, and this is the load, the critical load. To make control on the output here, as example, the voltage sag or voltage under voltage occurred, voltage reduced. What should I do? I should increase the voltage to back to the normal situation. If it is increased over voltage, I need to reduce. How I do this control? Very simple. Have a look. This is transformer for stepping down, because the voltage here, I want to step it down. I want to take just sample signal. I compare it with the reference voltage. As example, this is how I want the voltage to be at the output. So I compare it. If it is higher than or lower than, then I need to take action. Action will be error, coming here, amplifier to amplify it, and go to the circuit to control the switch operation of the inverter, as we discussed before. Everything already discussed before in inverter circuit. Now UPS could provide power not only for one load, for many loads. We need to connect them through either fuse or switch circuit breaker. Another arrangement is, have a look. We have AC here, electronic tab changer between switches by control, by signals. When it's connected, then this switch mode power supply, converter, will convert the AC coming from here into DC to charge the battery. And at the same time, power will go filter to make sure that we have a good quality signal going to the critical load. When shutdown occur here, the battery will work. Power will come from there. It is DC, it will convert into AC. Oh, this is inverter now. It's the same circuit, work as inverter, and supply the load. Okay? All of them lead at the end to make sure that we don't feel there is shutdown occur in our supply or disturbances occur in our supply. As I mentioned, usually in many countries, what they use for computer, they buy also UPS, uninterruptible power supply, connect with, because if they have, let me say, continuous shutdown in the electricity, they use UPS to make sure that they can work on PC. Otherwise, it will be off. Sometimes they use the UPS as a backup. Have a look. Let's assume this is the grid, the network. Electricity coming here, 230, 50 Hz, 230 volt, 50 Hz. And we have here anti-parallel thyristors. It's AC voltage controller. We control the output to the load. At the same time, this is UPS we discussed before. We put here also anti-parallel thyristor. We will not let these switches work at the beginning. Only power follow this direction. But when shutdown occur here, signal will come here to say, okay, you can start now working. And the power now coming from the battery to the load. As you can see here, these are UPS, you can see small size, large size, connected with computer. It's complicated sometimes circuits. This is also UPS, as you can see here. This is some power conditioner. You see, you can buy them from the market. It's not costly, 1 to 2. Some, as example, this one maybe 1.5 real. Okay, very cheap. So we want to make sure that there is conditioning occurred in our supply. I will stop here to continue next session with more applications of our power electronic converter and